So in section 5.4, we are now factoring quadratic trinomials. So quadratic meaning our highest degree term is going to be x squared, and trinomials meaning we have 1, 2, 3 terms. So we're factoring quadratic trinomials. Now in this case, a does not equal 1. So for example, in the first one, a is 5, right? 5 is not equal to 1. In the second problem, we have a 3. And in the third problem, we have a -2. So in all of these, we should notice that a does not equal 1. So when I factor these, I know we've already learned this in Algebra 1, and we did this in geometry as well. So if you have a different way of doing this that you prefer, that is okay. You can stick with your own way. I can think of 3 different ways off the top of my head that you can do these. So if you already learned this one way, feel free to stick with that method. But if you're kind of learning this for the first time again, this is the way that I like to do it. So first thing you have to do is you look for 2 numbers that multiply to be a times c. And those same 2 numbers have to add up to equal b. So the b part's the same as when you have a equal to 1, but the ac part is new. So what this means is that I have to take a times c. So 5 times -6 is -30. So I'm really looking for 2 numbers that multiply to be -30. But when I add those 2 numbers together, they have to equal b, and b is 7 in this case. So if I look at this, well, I know that -10 times 3 is -30, and -10 plus 3 is 7. Okay? If it is a challenge for you to think of those numbers that perform those 2 functions, you can make a list, right? I know it could be 1 times 30, or 2 times 15, or 3 times 10, or 5 times 6, right? And you know that one of these has to be negative, but the only one that's going to work for us is this option here would add up to 7. So you can make a list of all the factors and then figure out which one works best. All right, from here, I know that my 2 numbers that I'm working with are the -10 and the +3. So the way that I do this is I go ahead and I take the -10 and I take the +3 and I kind of put them in the bottom of these 2 fractions that I'm making. In the numerator of the 2 fractions, I'm going to end up putting this 5x, not 5x squared, but just the 5x. And so I have 5x over -10 and I have 5x over 3. And I want to now see if I can reduce any of these fractions. And I can reduce the first one, right? If I divide the top and the bottom by 5, we get 1x over -2. The second one I cannot reduce, so I'm going to leave that as 5x over 3. And this actually turns into my answer. So f of x is going to be x minus 2, and then we have 5x plus 3. And that is actually your answer. Okay, so we have gone ahead and we have factored this, and that's it. Let's try it with this one. Now, if I look at this one, you might say to yourself, oh, I'm going to take 3 times 30, and I am looking for 2 numbers that multiply to be 90 and add up to be -33. Now, that could get you to the right answer, but we're missing one thing. And we know from the earlier section in 5.2 that we said no matter what, I always want to start by trying to take out the GCF. So I'm going to take out the GCF because I notice that there is a 3 in common with all 3 of these terms. So 3 would be my GCF, so I'm going to take out the 3, leaving me with x squared minus 11x plus 10. So now I'm looking for 2 numbers that multiply to be 10 and that add up to be -11. And that's going to be -11 and -10 and -1. There we go. All right, because -10 times -1 is +10, and -10 plus -1 is -11. So that means I've got a 3. Now again, this is no longer a equals 3, right? A is a 1. So I can just really quickly write my 2 binomials. We've got an x minus 10, and we've got an x minus 1. Okay, so f of x, when factored, is going to be this whole thing. Okay, the important thing is that you don't forget this 3, right? You did factor out a 3 at the beginning, so you need to keep that 3 in your final answer. Okay, if I didn't have this 3, notice when I FOIL everything, x times x is just x squared, and I need that missing 3 there. So you cannot forget when you factor out a 3 or whatever number you factor out, you have to make sure that remains in your final answer. All right. Now I'm not asked to factor, I'm asked to actually solve this. So I'm looking for the x-intercepts, right? It's equal to 0. So I'm looking for the x-intercepts of this quadratic equation. So I'm going to again start by factoring. I'm going to take my -2 times my -9, and that gives me 18. So I'm looking for two numbers that multiply to be 18, but they have to add up to equal +9. That's my b value is 9. So I know it's going to be 6 times 3 because 6 times 3 is 18, and 6 plus 3 is 9. So in the bottom of my two fractions, I'm going to have a 6 and a 3. And then the numerator, I'm taking this -2x. All right. And so now I'm just going to try to simplify these. And so if I simplify these, we're going to go ahead and we are going to get, so if I divide these by 2, right, we get -x over 3, and we get -2x over 3 as well. And when you do this, we get something interesting, right? We get 0 equals -x plus 3 and -2x plus 3. All right, and you might be looking at this, you may be saying, well, wait a minute, if I were to distribute everything, -x times -2x is +2x, but we want it to be a -2x. But what we're not remembering is that, remember, if I set this equal to 0, it's essentially the same thing as if I divide everything by -1. And so you're basically just changing all the signs. So if I were to distribute everything here in my answer, right, we would get 0 equals 2x squared. If I do my outside terms, we get a -3x. Inside terms, -6x. Last terms, +9. And we can see that it's the exact opposite of what I started with. But again, because it's equal to 0, you can divide by -1, and it's going to be the same thing. All right, so it's not going to make a difference here. We will still get the same result. I just wanted to mention that in case some of you were looking at that and saying, wait a minute, that's not quite right. All right, it does end up working out for us. So we're going to get 0 equals these two pieces, whoops. And so I can look at this first part. I know that x would be 3, because -3 plus 3 is 0. And from here, I could plug this in and I would get x equals 3/2, because 3/2 times -2 is -3, and -3 plus 3 is 0. So that would be my answer. Okay, so we get 3 and 1.5, and we can go on Desmos and check this answer, right? So I'm going to go on Desmos, I'm going to type this in to Desmos, and we'll see if we get the right answer for my x-intercepts. -2x plus 9x minus 9. Let's see. -2x plus 9x plus 9. And we look, oops, minus 9 there, sorry, minus 9. So we look and we get 1.5 and we get 3. So we'd expect my answers to be 3/2 and 3. And if we look back, we do get 3/2 and 3. So we can verify that this does actually work, and we do get the right answer. All right. And that would be the way we do this. Now, if they were just asking you to factor instead of solve, you would want to make sure that you're keeping track of which one's positive and which one's negative, right? It's not going to work when you've got this negative floating out in front. So if you were just asked to factor, I would probably say factor out a negative. So you're going to take out a negative, and that's going to leave you with 2x squared minus 9x plus 9. And then you can go about factoring, all right? It always works best when a is a positive number. So if you're ever getting confused or forget what to do, I would just factor out a negative at the beginning, and then you can factor this normally to get your two factors, all right? Now sometimes, let's do a fourth example here. I might ask you to solve 0 equals, let's do 1/2 x squared. Let's do a plus 9. Actually, we just did some with 9. Let's do a different number. Let's do a plus 5, and then let's do a 3.5x. Okay. For something like this, whenever you have a fraction as your coefficient for a, again, 1/2 is not equal to 1. So we could go through the process of doing a times c. Well, 1/2 times 5 is 5 halves. So what multiplies to be 5 halves and adds up to be 3 halves? 3.5, sorry. Well, that's going to be a lot of work because now we got all these decimals to worry about, right? So what I would instead say is scrap this. And instead of doing that, I would just multiply everything by 2. So 0 times 2 on the left would get me 0 still. So we got 0. 1/2 times 2 is 1. 3.5 times 2 is 7. And 5 times 2 is 10. So if we multiply every single term by 2, we now have something easy where I can just factor this x plus 5, x plus 2. And then we know my solutions are going to be -5 and -2. All right? And those are going to be the intercepts. Okay? And again, we can go to Desmos and we can try graphing this. We can make the first term 1/2, and we can make this 3.5x, and we can make this a 5, and we can see that we do get -5 and -2 for those x-intercepts, which does match up with what we expected to get. All right, so there's a few different ways to approach this. Problems numbers 2 and 3 are going to be the big one, or sorry, 1 and 3 are going to be the most common ones that you see in this section, where you have to break it down and find your either factor or actually solve it and get your two solutions, okay? Again, I would just be careful if it starts with a negative out in front, maybe just factor out that negative first, just so you can avoid all confusion on that.